All right. Well, folks, if you joined us before, this is Cloud Computing Simplified, and you already know that. If you haven't joined us before, on Cloud Computing Simplified, we try to make cloud easier for folks to understand by going through some of the tools and processes and interactions that one might need to do to get going in cloud. So we've been trying to figure out how to use MRSK as an alternative to Kubernetes, or maybe a better Kubernetes. And I think it does actually address a common need, which is I want to containerize my application. I want to use the container workflow and container development processes, but I don't necessarily want to have to run and operate an environment. I just want to get my application up and running. And I might like to be able to scale it. I might like to be able to put it behind a load balancer, manage health in case the application itself breaks or can't talk to a database and therefore breaks. And so you can actually change health state. There's a lot to recommend it. In the previous session that we just ran, we tried to just sort of start from scratch. I hadn't played with MRSK really before. I'd only read the stuff online about it. And we found some glitches or some maybe misunderstandings in terms of how one is expected to set things up. And I did a little bit of research and found, I think, a better way to get going with MRSK. To me, if you're going to do container development and container lifecycle, then you're going to do it all the way. You're not going to have a local environment and work off of your local laptop. And especially if you're not a Ruby developer, you're not likely to have a Ruby environment on a local laptop. So I wanted to figure out how to get that to work. And it looked like there was an interaction at the Docker level where the tool was trying to talk to Docker directly, which is fine. There's nothing wrong with that, but we didn't have quite the right setup to do that. Well, I've got that sorted. And the other thing that I fixed here off screen and we'll go through is that the application expects to have health or some kind of a health check available to it. So my little test application didn't have that, so we've added that in. So we'll go ahead and look at those two components and see how the system actually behaves for us. So back to our screen environment. We still have our remote machine running, fi ssh root add MRSK. This guy's still up and running. And if we look here, there's nothing running here. Actually, I think even the images are gone, maybe. Yeah, so basically the system is clean on the remote system. If we do the same here, I've also cleaned up the Docker images. I've also cleaned up the local environment. And the big things that I've changed are twofold. One, the MRSK container. So we had built MRSK before using the Docker file from the MRSK Git repository. If we pop over there real quick, go ahead and have a look at this. So I created a Dockerfile dev. So the original Dockerfile started from Alpine-based Ruby environment running Ruby 3.2. Installed a couple of additional tools just so that it could actually build the application out. Installed the application, and by default it runs MRSK as an app. This is all fine. We built with the Dockerfile. What I did to change it, I created a Dockerfile dev. I'm going to map that back to Dockerfile because I think this is a better approach, although I don't know if this is the way that the MRSK community wants to run this, so maybe I'll just leave it as a Dockerfile dev and propose it. So I built from Docker with the Docker and Docker extension. So it still expects that the underlying host is running Docker of some nature, or it can run the Docker and Docker build X commands to be able to do potentially multi-architecture builds and things of that nature. I think that's all fine, and that should continue to work properly using this Docker and Docker approach. So this is from the Docker folks directly, so that seems to work at least with this local model and this local test. We're still going to keep all the rest is exactly the same as that file. The only thing I've done is change the default Docker and Docker, and I had to add in the Ruby development environment. So this was added into the Alpine Package Manager components and Alpine Package Manager cache. So that gets us to an actual running system. So then you can do Docker build for that just like you would normally. So we're in MRSK, so we can do Docker build local context. We want to call the app MRSK because that's what we were calling it, and MRSK latest is the right one. And then the only thing I have to do to use this specific Docker file is add a -f dockerfile.dev, because this is now the one that's going to build a Docker and Docker based image. I think it'll have to sort of do it all from scratch again. No, it looks like the cache is still there. So it went and it found in its cache that it had the Docker and Docker cached image, and the rest of the commands were also there. So even though I didn't have any images, I had the image of the cache. So I didn't think to clear the Docker cache. You could actually do this. I believe you say no cache. I think it'll download it again and then rebuild everything. So this is effectively the state that you would have had if you started from scratch, unlike my cached version. But end result is going to be identical. One of the wonderful things about containers is that if you have the same base, you should end up with the same result. Now, versions of things that you install, if you don't specifically lock, the specific version of Git or Ruby or what have you, then you're going to get the latest. But in general, this tends to work fairly well. So now it's building out the image, great, and now we have our MRSK app, and our aliases are still the same. Actually, that's not true. There is a change to the alias. So before, our alias included the SSH pass-through so that we could actually log in as root into our remote host. And that is actually an important difference from the documentation. It implies that you can use any SSH host user, and that's true so long as that user has root access to the system. My guess is that if you've already installed Docker and don't have to install any packages, you could probably get away with a user that already has Docker privileges on the host, because that's really all it wants. But if it fails to find Docker it wants to install, it expects to have root. So we ran into that as a problem earlier as well. The other thing is, for this Docker and Docker to work, we have to pass the Docker socket from the local running Docker instance. And so that's where this command comes into effect. So we have to pass in specifically the full Docker socket path. So these two aliases have been updated, and actually I'm just going to go ahead and grab these and edit this aliases.shell script that I created. Just clean that up so that I have a copy of that captured. Anyway, so that's the aliases. So we're passing the SSH directory so it can get to the remote host, and we're passing the Docker socket. So now we're going to go into our MRSK app example, and here the big change here was to the actual application itself. My application was just a really simple app. Flask, it passes a route and renders a template. It turns out I also had to change the Docker file because I was copying a specific file into the templates directory for the Flask application to work. I also had to change the target port just because without going in and specifying specifics to traffic. Traffic is going to assume that it's exposing port 3000. Why? Because the system was built around a mindset, which is a Ruby mindset, and the default port for a Ruby app, if you just spin it up, is port 3000. Anyway, with this, we're using Unicorn to run a Python Flask app, and it doesn't really matter. I think the simplest thing to do is just to fit into the default model. You want to have two things. One is you want to have your application, the container that runs your application, expose your app on port 3000. That's going to do direct mapping for the traffic setup. And the other thing is that you want to make sure that you have an up route, an up path. So in whatever language you're using, this is Flask. So basically here at Flask, I'm saying if I just hit the endpoint, I should get an index page, rendered index page. And if I hit the up endpoint, I should get a healthy page. And so I have two templates. There's an index template here, and this is just a generic, simple application Flask app page. It throws a page up, and then the other thing is that we also get a healthy page. So, and this could be actually absolutely nothing other than an OK. It just really needs to return an HTML response code of 200. That's all it's looking for. It's not looking for any text on the page or anything like that. So with those things, we can then go ahead and do what we were supposed to do, which was, we have our app, we have an example, we have the config. We can look at that again real quick as well. Config for deployment. And here we see we have our target. This is the EC2 server that we built previously. You can see that I don't have an SSH user defined, or the other path was also no longer there. Actually, we can go ahead and edit that and just clean this up. All right. Now, the registry is important, and being able to log into the registry, because the system actually builds and pushes the image, and then it pulls it back down to actually test it. So we do need to be able to log into the registry, at least for the push command. Turns out pull, if you have a public registry or a public resource that's being mapped in the registry, then you don't need this for pull, but you do need this for push, because we are going to build it. The other thing is that we've turned off the multi-architecture. So this is an x86-based host, so I'm just going to build an x86-based architecture. If I was on an M1 or M2 Mac, then you have the whole which host are you building for and which architecture type are you building for. If you're building for ARM on the cloud, so like a AWS Graviton targeted instance, then you actually do have to build multi-target as well in this particular case, because this would be ARM being built for a remote, or locally I would be building x86, remote I need to build ARM, so I have to have the right environment to go do that. Anyway, so that's the configuration for MRSK, and then if we now say MRSK deploy, I should go through. And again, the build will probably be pretty quick, because it's probably got a cached version of the image. It's not a very heavy build anyway. It's an Alpine Linux base with a Python Flask app, and it's basically a couple of packages that get downloaded. So as you can see, most of the layers already exist. 2 layers changed. That's just basically text that got saved. And here it's now getting things up and running. You can see that it's on 52, so it is actually checking on the remote host that the container is up and running, and it's doing that by checking the up endpoint. Looks like it was happy with that, and then it's running the instance and attaching it to the traffic machine, pruning old containers and images, and it's done. So if we actually hit this up, so we can do a curl here. We could just ask for the address, and here's the page rendered that we had. We can hit it in a web browser too. Figuring out what was going on with my Flask app. But if we hit this address here, then we get a little web page. And actually, the other endpoint that should work is up. I think that gets passed through, and you can see here it's saying healthy. I mean, these are very simple pages. You notice that we don't have HTTPS enabled, so this is not a secure path. And actually it's true for either of these, right? So this is also coming up as not secure, but it is a functional application that was deployed by turning on an EC2 instance. And this, in the future, we'll go ahead and do this with Terraform, because it makes life so much easier. And and MRSK. And once we figured out a couple of the glitches, right, you have to use root if you don't have Docker already installed on your remote resource. And then, of course, the whole Docker and Docker configuration for the MRSK build machine, which I think makes life a lot easier, a lot more streamlined. The other thing that we could look at doing is to actually deploy this with something like VS Code and the remote VS Code development and build extensions. And there you get the same sort of thing, right? Are you building in a local container, in which case you can start with the Docker and Docker container model for VS Code, and you can sort of build out from that. And then you would have a Docker and Docker container potentially with MRSK installed into it as an application, although you could also run a Docker container in a Docker container. I mean, that's all kinds of variants of what we might actually want to do here. But this way, at least you have a Dockerized MRSK application that you can run Docker and Docker as long as you start it up correctly. And that's what the alias does to make life, I think, easier in general on a development machine. This will work on a Linux or a Mac machine. And I think, as I mentioned in the show notes, if you're interested, then we can actually build a course out of this, and we'll probably post a link for a course pre-registration for those that might want to actually hop in and check this out. And I would say in general, this is still, I mean, the tool is there. I think that there's still a lot in terms of documentation, usability, and simplicity of spinning it up that one should be aware of. But in general, I think it's definitely an interesting approach. And the reason that I even wanted to try this was that I thought this might make a lot of sense, especially if you're building effectively a single page web app, or you're trying to capture some core data. The one thing I haven't explored here is how does this tie into something like a database, right? There's no database configuration and lifecycle management built into this tool that I've seen. There's no multi-container application deployment model. This is create a container and deploy it as a model. And these are all fine approaches. Again, even in the Kubernetes world, there's a lot of debate, even still, I believe, about where you should run your databases, how you should manage the lifecycle of your databases, etc. And so that's something that we can talk about more in a future episode as well. Anyway, hopefully you've had a chance to watch this and found this interesting. If so, don't forget to like, subscribe, share, point others at this stream, and we'll keep going. If you're interested in a course, all of our courses are on learn.qml.us. If you're interested in seeing more of this kind of content, don't forget to leave a comment here that you liked what you saw. Hit the like button. That also helps me know that people are watching this beyond just the 30 seconds of, well, that seems kind of interesting kind of a thing. And I'm certainly excited to do more of this kind of content for folks. I know that there is interest in general in cloud, but this is maybe a slightly different way of thinking about it and working on it. Anyway, thanks so much for your time. Again, share, like, subscribe, etc. The more we know that you like it, the more we'll do. Thanks.